Hello students, welcome again to another episode of our class. This is Alfred Explains Physics. As you all know, what we do in this class is to simplify complex concepts in physics into their lowest form for students to understand. Today I bring us conversion of galvanometer to ammeter or voltmeter. Now, from our basic electricity experiment, we are aware that the galvanometer is used for testing or for measuring the presence of small electrical signal, say maybe a voltage or current in an electrical circuit. The voltmeter, as we know, is used for measuring voltage or potential difference, and the ammeter for measuring electrical current. Now, how do we convert the galvanometer to an ammeter or a voltmeter? Now, a galvanometer is a basic electrical measuring meter for detecting presence of small electric current. Just a deflection of the galvanometer shows that there is current in the circuit. Now, for us to convert the galvanometer to a voltmeter, this is what we have to do. We connect a resistor here, a high resistor called the multiplier, RM, the multiplier resistor, connected in series to the galvanometer. When this is done, the galvanometer is automatically converted into a voltmeter. So the formula here shows us how much of resistance that should be connected in series with the galvanometer, for the galvanometer to measure for the voltmeter that we want to design to measure a particular amount of voltage. Now the voltmeter we have here only reads a maximum of 3 volts. If we want our voltmeter to read more than 3 volts, that value of voltage we want this voltmeter we are designing or converting the galvanometer into to read is what we input here. And then the particular amount of current of the galvanometer is given here. The galvanometer we are converting to voltmeter, its current value at full scale deflection is here. And the resistance of the coil. We know that the galvanometer has a coil in it. What is the resistance of the coil? We subtract that here. When we do so, it will give us a value of resistance. This resistance is called the multiplier resistance. It's what we now connect in series with the galvanometer. And so, by so doing, we have converted a galvanometer into a voltmeter that reads a particular value of voltage that we desire. Also, converting the galvanometer to an ammeter, here we have an ammeter. For us to convert the galvanometer to an ammeter, we connect a small resistance here, a small resistance called the shunt. This small resistance is connected in parallel with the coil of the galvanometer. And to do so, this is the formula that will do that for us. So that value of resistance that we convert the galvanometer into an ammeter is what we are going to calculate. Now, for us to do so, we want a desired amount of current. What amount of current do we desire that our ammeter reads at full scale deflection? Now, when the ammeter reads, for instance, this ammeter reads 2 value of current. We have the 1 ampere maximum and the 3 ampere maximum, which we can see up and down here. If we desire that the ammeter we want to design should read 3 ampere of current, therefore we substitute 3 ampere or 3 into the formula at this point. We use the galvanometer current here, and the galvanometer has also a fixed resistance. We use that here, and also the galvanometer current. So this formula, if we substitute a value of current, say we want our galvanometer to read 3 ampere, we substitute 3 ampere here, and then the value of the galvanometer current, galvanometer resistance, then minus the all over our particular current minus the galvanometer current, that will give us a particular resistance. If we should now carry that value of resistance and plug it in parallel with the galvanometer, that galvanometer has now been converted into an ammeter that reads this certain current for us. So this is how we convert a galvanometer to an ammeter. We can see here, this is a voltmeter. Across the voltmeter, we have a very high resistor. You can see here, let me bring it closer. A high resistor here connected in series here with the galvanometer. This was a galvanometer. We have a high resistor connected in series with the galvanometer, and it goes into the coil here, and this has converted the galvanometer into a voltmeter, as we can see from the circuit diagram here. Also, here we say we convert a low resistance or a small resistance called the shunt. Here we can see that this device is an ammeter. Initially it used to be a galvanometer, but has been converted to an ammeter. And here the ammeter measures two currents, current up to 1 ampere and current up to 3 ampere. So we should have two resistances connected in parallel with the device. We can see the first resistance here across here, meaning it's connected in parallel, and the second resistance also across here is connected in parallel to measure 3 ampere, here to measure 1 ampere. So we can see this connection. The value of the resistance are very small. For instance, I can see here we have 2.2 ampere from the color coding there, and here we have, I think, somewhere around 1.9 ampere here from the color coding. So this converts this galvanometer to ammeter. So this device is now an ammeter. Let's look at what is inside the galvanometer. As we have seen initially, the galvanometer has no resistance, so it is just a straight device, no resistance. When the resistance is connected in series, it becomes a voltmeter. When the resistance is connected in parallel, as we can see here, it becomes an ammeter. And these formulas will do that. So this is how we can convert a galvanometer to ammeter or to voltmeter. Thank you for joining us in the class today. Please do give us a thumbs up if you like the class, and if you are just joining us for the first time, click the like button there so that you see more of our videos when we post them. Thank you.